Let's now solve some exam questions regarding this topic of integration by parts. The first of which is from October-November 2013, paper 31. And we are looking at question 3. Find the exact value of integral from 1 to 4 of natural logarithm of x divided by square root of x dx. Here it is. So we need to pick up our u and our dv by dx. Our u here is going to be the natural logarithm of x, and our dv by dx is going to be the 1 over square root of x, or just x to the power of minus 1/2. I mentioned this before in our previous lessons that you can see in the Access Pro tier. How do you know which one to pick? How do you know that this would be u and this would be dv dx, or the other way around? Practice. That is the answer. Okay? The worst thing that can happen anyway is you pick this the wrong way around, and by wrong I mean there's nothing wrong with it. But if you would apply then this method, you would end up with a situation in which you would get an integral that you could not solve. And in that situation, you'd go to the beginning and you swap the position. Okay? So by sheer practice, I would know that this value over here, this part over here, the natural logarithm of x would be RU, and the rest, that is 1 over square root of x, would be my dv by dx. Once I have this, then I have to do du by dx, which is just 1 over x, and I do the primitive of that, so the value of v, which is 2x to the power of 1/2. Once I have all of that, then this will become this, all right? This part over here is u times v, so this times that, all of that between 1 and 4, minus the integral between 1 and 4 of v times du by dx, so this stuff times that, times dx. I already have put this 2 over here outside of the integral, and that's the, in terms of this topic, this is done. Everything else is just algebraic manipulation, right? So over here, I'm just already substituting by these values. Don't forget that natural logarithm of 1 is 0. So this part eliminates everything altogether. You just have to worry about the 4. This is going to be just x to the power of minus 1/2, which is very simple to integrate, okay, between 1 and 4. Just plug in the values, and here you have the result after factorizing 4. Another question. Paper 3 from May, June 2008. It's this question over here. The diagram shows the curve y equals e to the power of minus 1/2 x times square root of 1 plus 2x, and its maximum point M. The shaded region between the curve and the axis is denoted by R. Find the coordinates of M. That is the first question. Okay, the concept of solving this question comes from Math AS. So you have to differentiate it and equal it to 0. This is the maximum point, so this is a stationary point where the derivative is 0. So the first thing that you have to do is to differentiate that. You have the product of two simpler functions, so you have to do the product rule, okay? Your u is going to be this part, so du by dx is going to be this. Your v is going to be that part over there, so dv by dx is going to be this. I'm assuming that you know how to differentiate all of these by this point. So dy by dx, this is the formula, equals u times dv by dx plus v times du by dx. So you just substitute. You have all these 4 over here. Okay, so I just substituted, and then I just simplified. This is as much as you can simplify. And then what you have to do, this is the expression for all gradients. You want to figure out the value of x for which the gradient is 0, so equal this stuff to 0, which means basically leaving this on one side of the equation, leaving that on the other side. The e to the power of 1/2 of x is going to cut out, Then you just send a 2 to that side, send this to this side, you have square root of 1 plus 2x squared, which is just 1 plus 2x, and this gives the value x equals 1/2. So this coordinate over here is 1/2. The second part of the question asks you to find by integration the volume of the solid obtained when r is rotated completely about the x-axis. You know since last year that this is done by doing the integral between those 2 points of pi y squared dx. Now, what are the limits of integration? This one is simple, okay? It's x equals 0. But what is this one? You have to figure out the value of x for which y equals 0. So equal the function, the original one, to 0 and solve it. How do you solve this? You have here a square root. You can make square both sides of the equation. So this part over here will become just that. You get rid of the square root. 0 squared is just 0. So this is the same as that. When is this 0? This is 0 only and only x equals to minus 1/2. So the other limit of integration is minus 1/2. So a is minus 1/2, b is 0. Okay, so I already sent a pi outside. Y squared, I already know what it is because I used it over here. All right, I needed to square to solve that, so I know it's this. I just plug it there. In order for me to solve this, I have to use integration by parts. So u is going to be this part over there, and du by dx is going to be 2, and your dv by dx is going to be this part, meaning that v equals this. So this integral is going to be, I'll always leave the pi outside, it's going to be u plus v between minus 1/2 and 0. So this plus that, plus no, sorry, times. Minus the integral between minus 1/2 and 0 of v times du by dx times dx. I already sent the 2 outside. Also that minus, this becomes a plus. So I'm left with that. Integrating this is simple. That's what you get. Don't forget the minus over there. And then is just simplifying. That's what I did here. I factorized minus e to the power of minus x. This is what I have left. Combine, substitute by 0 and minus 1/2, and this is the value. All right. Pay attention over here. One tricky thing, it's very easy for you to lose minuses, etc. Okay, so keep an eye in your minuses and pluses. Last one, winter 2012, paper 33. We are looking at question, which one is it? It's question 5. The expression f of x is defined by f of x equals 3x e to the power of minus 2x. First, find the exact value of f dash of minus 1/2, and then find the exact value of the integral between minus 1/2 and 0 of f of x dx. So first one is applying the product rule. Second one is applying the integration by parts, pretty much like the previous question. Let me see how many points you have for this. 8. So here you have it. Pick your u. This is going to be your du dx. The second part is going to be your v. This is going to be your dv by dx. So f dash of x is going to be u dv by dx plus v du by dx. This is a product rule. Substitute each one of these by the things that you get there. Simplify. And then substitute x by minus 1/2. Simplify. And this is your answer. Integrating is going to be integration by parts. So this is going to be your u, this is going to be your dv by dx. So your du by dx is 3, your dv by dx is minus e to the power minus 2x over 2. It's just a primitive of that. Then the integral is going to be u times v between minus 1/2 and 0 minus the integral of v du by dx simplifying, continuing the simplification. All right, this is just algebraic manipulation. Factorizing. Once you have an expression that is as factorized as possible, meaning as simple as possible, you substitute by the values that you have, the limits of integration, this minus that, and this is the final result.